Oh yeah, so this is the beginning of our exploration of a different part of the math world. In my experience as a teacher, exponents is when it starts to get difficult conceptually for students to understand what's going on, and it's mainly because of the way that it's taught. But we won't have that trouble. We're going to analyze patterns, develop this conceptually, and avoid those formulas and resorting to memorization. We will be hopefully by the end of the series, we will be really advanced in our exponents understanding. So let's begin. Let's see how these characters act in this world, all right? So the main thing is that hopefully give you some time to analyze these 6 expressions. Which is the exponent, all right? In this first one, what's the exponent? The exponent is it 4 or is it 5? The exponent is 5. What's the exponent here? It is 4. Which one's the exponent here? It's the 3. What's the exponent for this one? It is the 6. What's the exponent for this one right here? It is the 2. Good, good. Be careful with that one. What's the exponent for this one? It is a 3. And if you're curious or you already know what the term for the other one is, if the exponent is 4, then what is the other one called? The 7. That's the base, all right? So all the bigger ones are the base. The exponent is that smaller number up here. Hopefully you remember that. Cool. But let's see how they act. What does it mean? It means that you have that 4 multiplied by itself how many times? That's what the exponent indicates. If you remember x squared, when we were doing quadratics, the exponent was always 2. So let's rewrite this one as 4 times 4 times 4 times 4 times 4. That's all that this is representing. 4 multiplied by itself 5 times. All right? Therefore, what does this one represent? It means a 7 multiplied by itself a number of 4 times. That's 3 and 4. So this right here is the same as this one right here. And that's what it means by rewrite in expanded form. This is the compact form, the shorter form of it, version of it, and this is the expanded form of the same idea. Therefore, this one represents 9 multiplied by itself 3 times. 9 times 9 times 9, all right? These two are equivalent. Therefore, down here, what does it mean to square this fraction? It means that we have 3 over 5 times 3 over 5. That's its expanded form. How many times are we multiplying the variable k by itself? 6. That's 5, I believe, and 6. There we go. These two are equivalent, just like these two are equivalent. And notice that sometimes it's very specific with parentheses what is being squared or what is being raised to the power of 3. In this case, it was not just the 3 or not just the 5. It was both of them, both of the numbers inside the fraction. Therefore, the parentheses are required to indicate that. And here, because there's a negative, it's more clear to have it inside the parentheses. So this one means -1 times -1 times -1. All right. So be careful with those. With that use of exponent, you make sure you know what it represents. The other ones didn't really have it, but technically there's parentheses for all of them. Look, there's the parentheses and there's the parentheses. I won't write it for all, but technically there is. It's just sometimes it's not written. All right, so that's the main idea of what's going on. Let's see a little bit more complex version of this. All right, just remember that there's a shorter format and there's a expanded format, compact form and expanded form. Let's do 3 more examples so that you can see, again, pay attention to the use of parentheses. What is the exponent of, is it 5, is it a 2, or is it a 3? The exponent is 3 and it belongs to the 2, not the 5. So that's why the use of parentheses here. So what this means is that we start with the 5. And then what's happening? We're multiplying 2 by itself 3 times. So then 5 times 2 times 2 times 2. You can think of it as this is this part. The 5 didn't change, but there it is. And same here, we're going to start with the 4. But remember that the exponent here now only belongs to the 3, not the 4. Otherwise, it would be another 5 here, or if these would be in parentheses or something. So then this one is going to be 4 times 3 times 3 times 3 times 3 times 3. I believe that's 5 of them. Yep, check it for yourself. 4 times 3, 5 times. All right. And therefore here, notice that the exponent of 4 only belongs to the 1/2. 80 doesn't change, so we will write this one as 80 times 1/2 times 1/2 times 1/2 times 1/2. No need to simplify any of these. We're just going to represent, again, this is the compact form to the expanded form. All right, so you can kind of see how these math ideas behave in this world. All right, and then I think what we want to do is reverse it now. There we go. So see, I've been already hinting at the idea of compact form. Let's reverse this. Suppose we start with the expanded form, and we want to, because most of the time we will not see something like this down here with, I don't know, like 8 or 9 terms. We would like the convenience of writing something very small to represent a bigger idea. Writing this green expanded form into something that's very compact. That's our goal. All right, so you count with me. How many total 9s do we see multiplied by each other? 1, 2, 3, 4, 5. Therefore, we can write this as what? Oh, the way we're going to read that is 9 to the 5th power, right? We don't say 9 exponent 5. We say 9 to the 5th power, all right? Just like, I guess I should have practiced that. This is 7 to the 4th power. This is 9 to the 3rd power, and 4 to the 5th power, all right? You can think of them like that. And therefore, we can write this one as 1, 2, 3. This is 12 to the 3rd power. Great. And then here I noticed these they have to be the same, right? Otherwise I can't count them as a 12 is not a 13 or a different number. These fractions are all the same. So how many times are we multiplying that fraction by itself? And the fraction is 7 over 2. I think I counted it 4 times. So 7 over 2, the whole thing in parentheses to the 4th power. 7/2 to the 4th power, or 7 over 2 to the 4th power. And then the use of parentheses is, again, very key here. It's -5 to some power, and it is power of 3. That's the compact form of that one. Hopefully the pace is good enough for you. I'm going to count how many times if you want to join in. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is m to the 10 power because it was the same factor of m. That's good. All right. So again, expanded form, compact form. This is way more convenient. And then let's see if we can see the little bit more advanced version of that. Are these all the same factor? Are they all the same? And the answer is no. All of them except the first one. So then we can still apply that idea. The 8 won't change, but can we multiply or represent the next few terms in compact form? And the answer is, look, they're all base 3. So we're going to say, all right, it's 3 times itself. 1, 2, 3, 4, 5, 6, 7. So this is 8 times 3 to the 7th power. All right. There's 7 of these 3s right here. Same idea for this one in the middle. Only the 5 is the term that is not part of the same base, but the other 3 can be written as 4 to the 3rd. This is 5 times 4 to the 3rd. If you like to write it as 8 times 3 to the 7th, that's fine. Or 5 times 4 to the 3rd, that's also okay. All right. As long as they're correct, they're both compact forms. All right, great. And then here again, notice that the 90 is not the same base as 1 over 3, but all the other ones do have that same common base of 1 over 3, and it is 4 times. And there it is. That is my main introduction to compact form and expanded form. There's not a lot of math that we're doing right now. We're just getting comfortable rewriting stuff. That's a lot of the key for exponents. We are going to emphasize rewriting exponents in different formats because that's what's going to make it way more conceptual in the future. All right, so either go on to the next video or have a good rest of your day. Bye-bye.